I'm going to walk you through how I configure Kubernetes cluster on AWS cloud using Terraform and Ansible. So this is self-managed cluster. This is not like a EKS or Fargate. So we are installing this Kubernetes cluster on top of EC2. So we are going to provision all the required infrastructure using Terraform, and we are going to configure Kubernetes cluster on top of EC2 instances using Ansible. So I am using Ubuntu 18.04 for this cluster, and this is the high level architecture. So we'll be having multiple available zones, and also we are going to have a highly available Kubernetes cluster. So we have multi-master cluster, master node distributed among different availability zones. So the cluster will be in the private subnets, and we will have Bastion host on a public subnet, so we can access cluster through the Bastion host, and we will be using private load balancer for the masternode API. So, and also we can have public load balancer for all the ingress traffic for the cluster. Let's quickly go through the code. And so in the vast TF, in here we define all the required variables. So if you need to change anything, you can change here, like AWS region. And important thing to note, so this AMI ID, so Ubuntu 18.04, this particular AMI ID is for US East 1 region. So if you are changing the AWS region, you may need to find required AMI ID for that particular region and update here. Apart from that, pretty much straightforward. All the availability songs and the VPCC IDR and private public subnet CIDR. You can configure how many master node you need, worker node you need, and I'm going to use T3 small for master nodes and T3 micro for worker nodes. So yeah, in here I'm just using VPC module for configure VPC for the cluster, and I'm using having Bastion host, and in user data script I can installing Ansible as well, and also I'm having master and worker nodes. So you can see I read the variable file and get how many master nodes and worker nodes I need. So based on that, I will configure master and worker nodes. This is the playbook we use for configure master and worker nodes. First, by default, we just installing Docker and adding Kubernetes repository, kublet and kubeadm. And here we are using that CRI dockerd shim for Kubernetes by default. Now Kubernetes not supporting Docker, so if you are using Docker, we have to use Docker engine shim. But if you are not using Docker, we don't need. We have other option like containerd, cryo. For master node configuration, so we separated it out as a two group, like for master first and master rest of the master node, because first we need to initialize one master node, then we need to join rest of the master node to the cluster. So we are using kubeadm. So we can initialize cluster like this, and for the control plane endpoint, you can see we are passing parameter master load balancer. So we are getting it from the Terraform. Terraform dynamically generate the load balancer, and it add it to the Ansible variable file, so we can refer it from here. Then just configuring kubectl for the Ubuntu user. And also we are installing pod network, so we are using Flannel for this example. And also we just generating and copying join command for master nodes and the worker nodes. Next section, that configure rest of the master node. We just copy the join node join command to the server. And configure kubectl and joining to the cluster. Rest of the work nodes in there also, we just copy the join command and join them to the cluster. Apart from that, load balancer, so we will be having private load balancer, network load balancer for master node, and we create a listen and target group and register the all the master node private IPs to that target group. And also we dynamically generate Ansible inventory in here. We provide all the master and worker node IPs and DNS to a template file. I can show you the template file in here like this. It will get all the variable and generate workers and master groups as per this template. And also one more thing to highlight, so we also dynamically create the private key and edit that key to Bastion host and the servers. So if you need to SSH the Bastion host, you can find, once you apply the Terraform code, it will create this create SSH key in your working directory, so you can use that key to SSH in to your Bastion host. That's pretty much of it. I'll add the GitHub repository link to the video, so you can go through the code slowly and see how it's working. So let's apply the Terraform code and see how it's work. It will be creating 46 resources. So basically it will create all the VPC and the public private subnets and the instances, load balancer, route table, and all the required resources. So we are going to approve the request. Now we have to wait couple of minutes until it create all the provision all the required infrastructure. And once the infrastructure provision complete, it will again run the Ansible script. So I'm running Ansible from the Terraform, and you can see the Ansible helper. So I generate inventory dynamically and copy all the Ansible file and inventory to Bastion host. And finally in here, once everything ready, I run Ansible script. copy everything to Bastion host and run Ansible from there. So yeah, let's see. All the infrastructure is still creating. So you can see that time sleep wait for Bastion, and it's why I added 2 minute wait time there as we are initializing Bastion host with all the Ansible and everything. Yeah, but instead of adding wait, we can improve the code later based on signaling. Yeah, that's a to do. Load balancer also still creating. Net gateway created, completed. Yeah, meanwhile I show you the repository URLs. Yeah. Kubernetes, AWS and LKRavi, that this is the repository, so you can have a look. Still waiting for some of the VPC module component. Private net gateway still creating. Meanwhile, you can see the AWS console. Yeah, we can see Bastion host and 3 master nodes and open nodes created. You can see Bastion host is in public subnet, and the master nodes they are in private subnet. And also you can see there this one is in 1A and this one is in 1B and this one is in 1C, so it's distributed across all the availability zones. Let's see. Yeah, the infrastructure part completed. Now it's starting the Ansible playbook. So it's already connected to our Bastion host and start running Ansible playbook. It's running. Installing Docker. Adding Kubernetes repository. Installing Kubelet. Installing kubedm. Now configuring that Docker regime for Docker. Yeah, now configuring first master node. Starting the cluster. As this is a multi-master cluster, first we have to start with one master node, then initiate the cluster, and then later we have to join rest of the master node. We cannot configure everything together, so that's why the first masters first and the masters rest we are configuring separately. Yeah, cluster started. Now waiting 20 seconds. Okay, configuring kubectl. Yeah, copying join command. Yeah, now configuring other master nodes. Yeah, now joining other master node to the cluster. We copy the join command from the first master node and then execute it in the rest of the master node. Okay, joining complete. Now we have worker nodes to complete. Yep, same thing for the worker nodes. Yep, completed everything. Worker node successfully completed. Okay, as output we got the Bastion host IP we can log in and see. We're just going to SSH. As I mentioned, we already dynamically create gate SSH key, so we can use that key to SSH to the Bastion host. Okay, we are in Bastion host now. Yeah, we can get one of the master node private IP. As we already configure all the shared all the key with the servers, we can just SSH. Yeah, now we are in master node. We can see kubectl get nodes. Yeah, we can see now we have 3 master nodes and 3 worker nodes, and also we can see kubectl get pods. Yeah, we can see all the etc API server, and also we install Funnel. Drug driver and proxy and scheduler, everything up and running, all good. Yeah, and I need to show one more thing, the load balancer. Yeah, so you can see it's configured. We have listener configured, and it's forwarding all the API traffic to this target group. In there we have added all the master node IP addresses, and all the nodes healthy and forwarding traffic. Yes, that's pretty much of it. Now we have working Kubernetes cluster. Thank you very much for watching.